All right, so I've gotten as far as I can. It's 10:30, and I need to be up early tomorrow for the flight. Got to go pack the car, so I'm gonna call it here tonight for me. So what I'm doing is just making a quick video to describe what needs to get done before the first flight on Thursday. Um, I drew one, but basically this cap here needs to get mirrored for this side. I didn't have a chance to draw that side. It's a little tedious getting the dimensions, but you just use the measure tool, snag those dimensions and draw one up. And then just match the whole dimensions I have here, the whole diameters, because I was going to use the 2.5 millimeter hardware box just because that stuff is a little bit lighter. Um, and yeah, that's what I was going for there. So that other cap needs to get made. And if you want as well, what I want to add, so you see this little zip tie slot here. One, it is too small. Bump this up to like 5 millimeters. See where my mouse is down here? Bump that up, and then as well make it a little bit wider, like the slot here. This is a zip tie slot. And what you're gonna do, you're not gonna necessarily move this, but you can kind of get rid of this guy here and move it, not move it, but redraw it down here, kind of where this line is, because right now, um, when you get the part from Julia, it's in her possession right now. When you get it from her, you'll see that the zip tie is like strapped around the radio right here, and that's holding it in really well. I originally thought I was going to put it here. However, these zip tie slots were too small for the red zip ties that are in the box. And um, as well as the radio kind of sits below this ledge. So when you zip tie it, like it does constrain it, but it doesn't like keep it snug. It can wiggle around because the zip tie doesn't touch the radio. Like it pokes out here, but it's sitting below this wall in the real one. So a more effective zip tie placement is right in here. And so you can put a slot down here on this, extruding off of this wall, the same slot concept, just extruded off of this wall. So that's what needs to get done there. And then if you look, I guess I made a mistake last night and didn't save the last two cuts I made before I 3D printed it. Because if you look at this guy, this is the 3D printed model, or the STL file. It's got these two holes cut in it. So you can go ahead and cut those back out. I'm not going to do it right now because it'll just send me down the rabbit hole of continuing to fiddle with this thing. So yeah, that needs to get done. And then I printed it on 15% infill, but I guess whatever the employees at the iHub want to do. And what else? Yeah, again, mirror that. And then anywhere else you see to save weight, go for it by all means. If you think, I don't know, you can cut some holes in this part to save some weight, anything. I mean, I feel like the weight battle is going to be won and lost in the details, because effectively all of these things are a net zero. All of these components that everyone has, they're a net zero. So it's just going to come down to the details. As far as like, our battery hooks up, like the placement of the VCC or the VN and the ground on the Arduino are like right here. So it's really close to the battery. And and then all the digital pins that connect to the radio are on this side, and again, the digital or the pins for the NRF where you're going to solder it are down here. So it's a really short path. The stuff just got to scooch across this little lane. So actually, something you can do if you really want to be like really slick is you can add a little extrusion here for the wires to pass through that'll hold them in. Not necessary, but just again, more details. I liked everything about how the weather shield mounted in and the cable routing there. I designed for the shortest cable that we had, and that worked out. Everything's good there. If you want this cut here, this extrusion, you can open this one up a little bit more to allow more space for soldering. Because what you're gonna have to do is you're gonna have to put this in here and then solder it to allow the wires to kind of sneakily like pass through this hole. So that needs to happen. Another place to save weight would be on this bottom side here. You could cut out below the battery. I mean, obviously leave like a rim for the battery to sit on, but it's pretty snug in there, so it's not going to wiggle into this hole you're going to make. So that's a place you can save some weight. And then, you know, maybe you could even try and save some weight on this guy. So again, I mean, I guess it's just all the things that I've said, and then just look for places to save weight, because we just, you know, there's points for being the lightest design, and we got to get as many points as we can. And that's, you know, like I said, all this stuff is a net zero. So the difference comes in how much wire you got and how much 3D printed material you have. And again, I guess the bolts as well. So, you know, maybe we only need one of these bolts, not two right here. Maybe we only need one. And as well, add a fillet on this guy, on this Boss extrusion for the bolt, because I think I cracked the other one when I was screwing in the bolt. So that could use a little beefing up. And yeah, and feel free to, you know, if you see something that could be improved. I feel like I've really kind of combed the design, optimized for placement, and everything on the design, on the one that's printed now, is really solid. Like I can thoroughly shake this and nothing rattles or acts like it's going to fall out. So I think what we have is pretty solid. And, you know, worst case, we can zip tie. You could just, you know, model in, might not even need to model it in. Well, you need to put like little zip tie slots up here, but you can go through this hole for zip tying it onto the drone. If by Tuesday you can't have something drawn, I mean, I'd rather not zip tie stuff to the drone, because I feel like that's just, I mean, it works, but I'd rather do something a little more professional and sleek than zip tying it to the drone. That's why I was trying to go first for the snap fit design, but that proved a little too difficult to do. So we're going to try these caps. And then of course I got the clearance for the bolt head. Yeah, I know I'm kind of really jumping around here, but you know, it's a video. You can replay it, stop it, pause it, watch it again. So yeah, I hope this helps. And how I've centered spaced, like, so what's critical for mounting it on the drone is the center spacing between these two that goes on the legs of the drone. And if we come over here, how I've center spaced these is a plane, this guy. So it's just, they're kind of, the circles are kind of mirrored over the plane. And this is a lofted cut, is how I made these cuts that are at like a slant. So yeah, that's that. Hopefully I'll hear that it was a good flight. I'm excited. I've enjoyed designing this, because it's been been a good challenge to get everything to be so intricate. And so, you know, it is like 90-degree geometry, but it's like, it's not just extruding rectangles. This is like intricate. So hopefully it pays off for us with, maybe getting awarded with, maximizing the amount of points we can with the design. But all right, that's everything I have.